Hello friends, this is Jim with Science Talk. In this video I want to describe to you what happens with lakes. And specifically what happens with the mixing regimes that takes place in the lakes and the different types of mixings that take place. In the past videos I've discussed with you, for example, when I talked about the AMOC and the conveyor belt, I talked about density and how water can vertically sink and move along, and then when we form the North Atlantic deep water, that's cruising along at about 1,000 meters deep or so, and eventually, because it's flowing, it's interacting with other water masses, there's friction involved, so then heat is imparted to the water mass, and heat will then cause it to become less dense, a little bit of thermal expansion, so the water starts to rise, it upwells, bringing nutrients, and then we have the wonderful productivity of the Southern Ocean found near the Antarctic divergence zone. Now I mentioned that in seawater the density is determined not just by temperature but also by the salt content. So you can have cold, not as salty water and very warm and salty water. Which is more dense? Those are not easy questions to answer. And it really depends on the physics, it depends on the interaction of the water masses should they meet up, and so forth. And we construct these elaborate, what we call TS curves, temperature salinity curves. And it's an art to analyze and interpret those graphs. But they are informative, they do tell us of the mixing. So I want to step back and describe for you typical mixing regimes in fresh water, and in the hopes that by doing this video you will get an idea of the kind of mixing stuff that goes on in the ocean. Because in fresh water, temperature is the sole factor to determine water density. Now, because of the nature of the water molecule, the polar covalent bond that takes place between the oxygen and the hydrogen atoms, as well as the hydrogen bond itself between adjoining water molecules, water is most dense at 4 degrees Celsius. This is fresh water. So as you cool the water past 4 degrees Celsius on the way down to 0 Celsius, which is where, of course, water will freeze, the nature of the molecules, the way they line up, the geometry of it, it starts to expand. Which is why when ice does form, it expands, it is therefore less dense, and ice therefore floats. If that were not the case, it would just, as you keep cooling it down, it keeps getting more and more dense, it would just be frozen solid, and you would all the lakes would be frozen ice cubes, and probably as well as the oceans would be frozen ice cubes. You might remember that the more salt you add to a system, the lower the temperature is where it will freeze. It's called freezing point depression. And as I said, it gets very, very complicated when analyzing salt water as far as the density, mixing, and what's going to happen, and so forth. So, as I said, I'm hoping in this video, by explaining what goes on in freshwater lakes, you can then have an idea of what happens in mixing with density consideration, and then later on we can then describe in more detail typical water masses in the ocean and what happens when they meet other water masses, what kind of mixing takes place, what happens to the resulting density, which water mass sinks, which rises, and so forth. So let's start out with a typical temperate lake, a lake that's found at temperate latitudes. Think of a lake in, say, Pennsylvania or New Hampshire, what have you. So let's say we start out with wintertime. We have this lake, there's ice on the lake. Okay, what's happening underneath there? Well, we have this ice, we have a stratified water layer. Now, depending on the type of lake, you could have loss of oxygen, increase biological oxygen demand. It's not uncommon to encounter situations where there's fish kill, where the fish die off because lack of oxygen. We're going to set that issue aside. We're just going to talk about the physics. So we have this lake. It's covered with ice. Ice is at 0 degrees Celsius. We now move into spring. This ice starts to melt as heat is put into it. So what happens? As it melts, as it warms up to 4 degrees. That's where fresh water is most dense. So now we have the surface water of 4 degrees. It's at the surface. It's at its most dense. What's going to happen? It vertically sinks. And when it vertically sinks, typically it will sink throughout the entire water column, surface to substrate. It will do what we call an overturn. So you have a nice mixing of the entire water column. This is good because there might be some nutrients at the bottom. They'll bring the nutrients up to the surface. Just like I talked about with the rise of the deep water in the Antarctic divergence zone. So this is taking place during the springtime. Things continue to heat up. You get into summertime, it gets very, very warm. And now we have very warm surface water. That's extremely less dense. It's now to the point where it's not dense enough to sink. Now that layer stays stratified. You have a layer of warm water overlying a colder water. In the process of making that stratified layer, those nutrients from the overturning will be trapped in the photic zone. Any algae, phytoplankton, what have you, can now, they're in the photic zone, so they have the light energy, they can carry on photosynthesis, there's dissolved CO2, they can access is a better word, they can access the nutrients and engage in primary productivity, which of course then leads to, the primary consumers, secondary consumers, etc. So that's what happens there. So you have the spring overturn, that's the first mixing. Continue warming up leads to a stratification, where you have warm water over cold water. The transition zone between the water layers is called a thermocline. Thermo for temperature, cline for sharp division. And typically, if you were to drop a thermometer vertically through the water column, you'll see that the upper layer is pretty uniform. So you might have the same temperature, and then all of a sudden you hit the thermocline, and what happens? You see a sharp bend in the graph, if you will, a sharp decrease in the temperature, and then it may be uniform down to the bottom. That layer where we see the sharp bend, that's your thermocline layer. So we see a layer of uniform temperature, a region of drastic decrease in temperature, and then the rest pretty much a uniform temperature down to the bottom. And that region of drastic reduction in temperature is your thermocline. So now, as summer proceeds into the fall, what happens? The surface layers begin to cool down. So now the temperatures start to reduce. So now the surface water, because they're cooling down and becoming more dense, keep cooling it down, you get to that 4 degree mark, and what happens? The surface water sinks again. So we have a repeat of what took place in the springtime. We have another top to bottom overturn, another top to bottom mixing. And then you continue to cool down, you form the ice, the cycle repeats. Such a system, typical for temperate lakes, where we have two major overturns of the water column per year, is called a dimictic lake. Di meaning two, mictic, M-I-C-T-I-C, is referring to mixing. So basically this is a dimictic lake, is a lake that has two mixing events every year, spring and fall. And that's typical for lakes found in temperate latitudes. Now, what happens if we have a lake that's, say, in the high Arctic? Well, there's a number of possibilities that can happen. One is that instead of having two mixing of the water column per year, you might only get one. Because it's so cold most of the year, or there's ice most of the year, that it's only until you get that brief summer where the ice melts, you get it up to, again, 4 degrees C, and it sinks, and you overturn the water column. And then before long, it freezes back up again. Such a lake is called monomictic. You only have one mixing event per year. There are some cases where the lakes, the water never gets to the density such a point where surface layers are dense enough to sink vertically. Therefore, there are no mixing events at all. Such lakes are called amictic, A meaning without. So you have dimictic lakes from temperate. You start getting into the high Arctic, and you could encounter lakes that are monomictic or amictic. Now, it should also be noted that you could find some lakes in the tropics where it's always warm, that the surface waters are, again, so warm that they just don't get dense enough to sink. So you could have situations of amictic lakes also in the tropics. Or likewise, maybe it just cools down enough during what we would call winter time, where you get one mixing. So in the high Arctic, if there's a one mixing event, it will occur during the summertime. In the tropics, it will be occurring during the winter time. In all these cases, dimictic, amictic, monomictic lakes, there's another possibility. There's a possibility that the water, if it mixes, if it overturns, it may not overturn all the way down to the bottom. That could be depending on the bathymetry of the lake. Is it a deep lake? In which case the density may not sink far enough down to reach all the way to the bottom. In other words, you have an incomplete mixing of the layer. The upper layers, and maybe it could be the upper 2/3, upper 3/4 of the depth of the water could mix, but the bottom does not mix. And a lot of times becomes anoxic. No oxygen is there. And typically, unless you're looking for anaerobic bacteria, you're not going to find aerobic organisms there. Such a situation, and it can occur anywhere. It can occur in the tropics, it can occur in temperate, high latitude, where you have an incomplete overturn of the water column. We call that a meromictic situation, M-E-R-O-M-I-C-T-I-C. And sometimes you'll see the term mixomictic, but meromictic is the term that I'm familiar with. And when you have that situation, you can therefore end up with areas that are, the bottom layers are anoxic. We also find such regions in the bottom of the ocean where that can happen. You have anoxic regions in the bottom of the ocean. Of course, once you're out of the photic zone in the ocean, any organisms found below the photic zone are dependent on detrital material that sinks down through the water column and that they encounter. Or you are near a hydrothermal vent. Hydrothermal vents do not rely on light energy, they rely on chemical energy. So they are independent of that. And these are your typical, your smokers as we call them, with the hydrogen sulfide coming up under high pressure and temperature out of the Earth's crust, out of the fissures. And because of the very high pressure, that does not boil, it stays in solution. The chemotrophs can utilize that, and we have a whole separate little ecosystem there. You've probably seen photos of the tube worms and so forth. There is the current thinking is that this is where this is most likely the first types of life on Earth before there was sufficient oxygen in the atmosphere. Anyway, that's a little side note there. So the point that's usually needed for productivity in any aquatic system is you need an overturn event. The overturn event will mix in nutrients throughout the water column, and then following the overturn event you need stratification. The stratification keeps the nutrients locked in the photic zone. It is also where the phytoplankton will be locked in, if you will, and they have access to the nutrients, they have access to CO2 that's dissolved in the water, and of course in the photic zone they have access to light energy. So that's what you need for productivity. Mixing followed by stratification. Now, if you start doing things to the systems, anything that inhibits the mixing will spell trouble for the ecosystem, for the productivity, for the food web, and so forth. That is true whether as I described to you the Antarctic divergence zone. That is true for something like that. That is true for a lake. It could be a little tiny lake. It could be a huge lake. It could be one of the Great Lakes. It could be Lake Baikal. It could be Lake Titicaca, Great Slave Lake, Great Bear Lake, what have you. It could be any situation that inhibits, slows down mixing, will prevent or limit how much nutrients can be mixed into the photic zone during stratification, which will decrease productivity. So these are other things that we need to be looking at. Are we seeing such events taking place? And I know there are scientists working on that question, and I will be sharing with you in upcoming videos some of their findings. Basically, the answer is, spoiler alert, the answer is yes, productivity is being compromised, is decreasing. If you like this video, please share with others you know. Please share on social media. Please subscribe. Hit the bell so that you know when I drop a video in. I hope you will consider supporting my work at Patreon. Patreon.com/Science Talk with Jim Massa. Very, very nominal monthly rate, but it means a lot to me if you can support the work I do here. If you are already a patron, thank you for your support and continued support. Thank you for your time.